show you how to add and subtract like terms, what it means in the real world, how to work it out when you get it on paper. And lastly, we're going to review. We're going to go over some problems that are a little bit harder. We're going to go over problems of when you combine like terms and problems when you don't combine like terms. So I'm excited to get into the lesson, and I can't wait for us to learn and grow together. Greetings, Education Builder students. Some of you might have heard your teacher ask you to do something like simplify. You might have heard the word simplify or seen it on paper, and you didn't know what it meant or know what to do. Well, in algebra today, we're going to learn how to simplify by combining like terms. That's using addition and subtraction. And before you learn how to do that, there's some terms that you're going to need to know. So we're going to go over some definitions, and you will have these definitions in your workbook in front of you as well. Okay, we've already gone over some definitions that you use or you'll see when you combine by like terms, and I want to review those with you real quick before we move on. Remember, if we have the word term, that means letters and numbers separated by either an addition or a subtraction sign. If you have the word variable, variable means letters, so A, B, C, D, E, F, G, all the way to Z is a variable. A coefficient is a number. That's what a coefficient is. We're reviewing these definitions. And lastly, remember, an expression is when you have more than one term. So we're going to go into actually combining like terms now. We're going to go over what it means to combine like terms. If your teacher says to you, what is combining like terms, or what is like terms, what she's saying is you need to combine the same things, things that are alike, things that are the same. In math, we know that you can combine numbers. We know that you can add and subtract numbers, right? You know that 1 plus 1 is 2, 2 plus 3 is 5. So all numbers are considered like terms because they're something else that you might see in algebra, and you might ask yourself, I wonder if I can combine like terms on this. She told me that the numbers are like terms, and she said that as long as the letters are the same, I can add and subtract them, no matter how many letters there are. But say you have something like this. Let's use the letters A and C. Say you have something like this. A, C, plus 3. A, C. What do you notice that's different about this problem? Well, remember, we have two variables here, two letters. We have AC here, and we have the same letters on this term, AC on this term. Now let's look. Remember the word coefficient, that means number. You don't see a coefficient here, but you do see a coefficient here. You see the number of 3. So you say, she said if it had the same letters, I could combine like terms, but I don't know how to add this. I don't know what number is here, or if there's a number here at all. Guess what? Anytime you have letters and there's no number, you can always put a 1 in front of it. So now that should look more familiar to you. Can you combine like terms? We have numbers and they have the same letters. 1 plus 3 is 4, and they both have what? AC on the end. Let's try another one. Say we have something like this. Well, we see that all of these have XY. So it follows the rules of having the same variables, but there's not a coefficient here. Now, what did we learn from this one when that one didn't have a number? We did what? Just stuck that one in front of it. And since these are all addition, we can add them. 1 plus 3 is 4. 4 plus 2 is 6. And what do these all have on the end? XY. Now I'm going to show you a little harder problem. Now we're going to go into more detail about the commutative property of algebra. order changes, it would become B plus A. Now remember, we said it was for addition. It works for addition, so let's see. Is 5 plus 3 the same or equal to 3 plus 5? Yes, because you get 8 on one side and 8 on the other side of the equal sign. So this is an example of the commutative property for addition. Let's look at another one with multiplication. We have A times B equals, now remember, commutative property is when the order changes, B times A. So now we're going to try it with numbers. Is 7 times 2 equal to or the same as 2 times 7? Yes, because we get 14 on both sides of the equal sign. 7 times 2 is 14. 2 times 7 is 14. And this is an example of the commutative property of multiplication. 7 times 2 is 14 once again, and 2 times 7 is 14. Now let's look here. It says the commutative property does not work for subtraction or division. Let's see why. If we have A divided by B, will it equal B divided by A? Well, let's try it with numbers to see. 4 divided by 2 is 2. And 2 divided by 4 is not 2. 2 divided by 4 is 1/2. So they do not equal each other. This is an example of why the commutative property doesn't work for division or subtraction. Look at a subtraction one. Is A minus B equal to B minus A? We use the numbers 5 and 2. 5 minus 2 is 3. But 2 minus 5 is negative 3. You don't get the same answer on both sides of the equal sign. So this is another example of why the commutative property does not work for subtraction or division. Welcome again, education builders. I first want to start off by going over some vocabulary for today's lesson, order of operations. We're going to start off by defining the word algebra. Algebra is a type of math that takes an unknown and makes it known. It's basically finding the answer to something that you don't know for real-world situations. Next, we're going to define expression. An expression is a mathematical phrase